Hey everyone, how's it going? I just spun up our recording session. Shh. Hey, stop it. Hey, you're interrupting. My dog's going ape over here at the window. So I only received, I don't know, what is it, 7 or something Skype names. We have a Skype chat spun up right now, and we have 2 students in there. So, hi. All right, well, at this point, I'm just going to basically open up the Word doc that I threw on Google Drive, so I'll share that out here. If you go to the Google Drive, there is a Cyber Forensics Workshop Day 2 Notes Draft. And let's just share this bugger out. There we go. So I still really like the idea of kind of building out our curriculum on the fly, but I put together some notes specifically because I heard that we had some questions last time about how to perform certain tasks, for example, in Wireshark. So I'll be a little more verbose in the notes and provide some more specific links. Hopefully that'll help out. So I'll provide the YouTube link when we're done here. Today, one of the things we want to do is cover the... by the way, I want to mention someone in Skype is trying to initiate video calls. Skype is just going to be used for chatting, like actual text chatting. So we're not going to be using Skype for a video call because I'm just streaming via the Hangouts. Plus, Skype won't allow more than 10 participants for a video call. Then again, there's only 2 students in there right now, so maybe that could have worked. But anyway, we're going to explore some tips and tricks since last time. And let me just flip the screen back over. So one of the things I mentioned that was a possible homework assignment last time was to learn how to convert hex. And I'm sorry, I had to let my dog out. Jeannie, come on. Far too annoying. See ya. Alright, anyway. So, to convert hex using Python. So what I did is I spun up, in fact I have a fun script coming up that I wrote last night, but I just wanted to show you quickly how you can do that. So let's see, I want to do a test real quick. So in the chat right now, I have my chat over to this screen, which is where you're going to see me looking over here often. So in the chat, I want to put the time right now, and I'd like someone to, in the chat, to tell me how long it takes for you to see what I have said as opposed to what I've typed. I want to see how much delay we have. So if I put the time in right now, basically just when you hear me say it on the stream that I've just done that, just type something. I'm assuming we have around 30 seconds of delay. Hey, another person shows up. Here we go. Let's add you. Well, that experiment didn't work. No one typed. So, all right. Well, whatever. We have currently 3 students in the chat room in Skype. So again, Skype's just going to be for typing, whereas this will be me staring at the camera. Like this. All right. Well, one of the homework things I mentioned was, again, to convert hex in Python. So in your notes, I've put something for you. Let me share that out real quick. Patrick's going to help with our timing. All right, let me try something right here. All right, Patrick, I'm going to do it now. Oh, well, That's not much delay at all. That's like 2 seconds. Oh, perfect. Okay, cool, man. So, anyways. Awesome. Oh, okay. So it's about 15 seconds behind on the actual video. Okay, cool. So going back to this guy here, one of the homework assignments again, converting Python. So what I've done is I've provided you two different options. For this particular course, I requested that you guys install Python 2.7. That's pretty much the programmer's preferred version right now. And if I started any debates with that, we could take it offline. But it's very easy to do this in Python 2.7. So unfortunately, the first way I wanted to show you using just simply .decode, this guy right here, does not work in Python 3 and above, and that's because they dropped that particular feature, and they went with hexlify, which is fairly powerful, but I kind of miss having the simple .decode. So one thing to note is that in Python, everything is an object. So a string is an object. I know some of you are programmers, so you can easily respect the fact that they are non-mutatable or immutable, excuse me, sorry. But at the same time, you can do a lot of really cool functions on them by just doing a dot and then whatever you want. So I love that feature of Python, and I'm going to show you here. So I'm going to share out my Python screen now. Hi, wasn't found. Who did funk? Alright, so if I open up Python, you'll see here I'm running Python 2.7.6. By the way, I'm using a Python version that was built by Apple, included in OS X. I, in general, do not condone the use of this version. If you're wondering why, just go Google like issues with OS X Python or something similar, and you'll see exactly what I mean. So anyways, all right, in here, let's just say that we have a hex string that we need to decode in Python. Well, as the homework shows, we can simply put string goes here, dot decode, hex, just like that. Now, that's not hex, that's going to fail. But if this was hex, let me go get some hex to decode. I could jump ahead to the next thing, but I'm just going to cheat real quick. Alright, so I just grabbed a string. There you go. So we have a hex value, right, a string, and then just .decode hex. And there's the decode. Now, unfortunately, that gives us a different value than the value I entered. See that? Why is that? Well, it's because that option kind of sucks. Don't use that. So a secondary option that I have in your class notes is to use what's called hexlify. And I give you a link in the class notes. So I'm going to pull up the link now. Hi. Where'd it go? Oh, right there. Alright, so in Python 3, the preferred version to convert between binary and ASCII is to use bin ASCII, which is pretty gnarly. And there's a little function down there, hexlify and unhexlify. And yeah, it has a silly name, but it does exactly what you think it would do. Oh, I'm sorry, my screen's a bit small. Bigger. Bigger. There you go. So, pretty simple. Turn it into hex, decode it from hex. Really easy to use. So, as I mentioned earlier in session 1, documentation is all the rage these days. There's so many libraries available for Python. There's so many tools available for forensics, digital forensics, computer forensics, and network forensics like we're doing, that it's just, you can't not just run a Google search and see what you find. So, I literally typed in, I don't know, a year or two ago when I was testing out Python 3 and I was very annoyed. I typed in something similar to convert hex to ASCII Python and it popped right up. Said, hey, cool, that's cool. Let's use that. As a note, when you're looking at documentation and on the Python site, docs.python.org, the top left-hand side up here, this guy right here, oh, it's not showing the drop-down menu on the stream. Well, that sucks. Well, when you click this drop-down, you can choose the version of Python. So again, I highly recommend you stay away from the 3-dot versions. They're horrible. I'm whispering. All right. Anyway, so let's take a look at using bin ASCII and Hexlify. Okay, let's. This is bothering me. There we go. All right, so I want to convert something here, so I need to use bin ASCII and then Hexlify, right? So let's do this. Testing equals bin ASCII dot Hexlify. Oh, well, obviously, sorry. I have to import it first, of course. There we go. So that's as easy as that. I run import bin ASCII, binary to ASCII, and then I've just set a variable here, testing equals bin ASCII, and then dot Hexlify, and then my string. And then I've just printed my string out. Now, I can also convert it back. So I'm simply printing on the fly the result of bin ASCII.unHexlify testing. Or if I wanted to do this, there we go, into its own variable. So fairly easy process using the bin ASCII conversion between binary and ASCII in Python. Cool. All right, let's go back, and I want to just talk a moment about taking notes. So when you're performing a forensic investigation, one of the most important things in the world is note-taking. Not just note-taking, but think of it more like record-keeping. When you start getting into physical forensics courses, you're going to learn about things like chain of custody forms, unless you've already gone over that type of stuff, that require tracking whatever assets you're collecting from A to Z. Anyone who so much as lays a finger on it, or in some cases lays like their eyes on it, you need to have documented who it was, where they were, what time it was, why it occurred, so on and so forth. So note-taking is very important when it comes to forensics, but it's also very important when it comes to just analyzing something forensically. So for our class, we're not going to be taking this to court. We're not collecting evidence on some employee misconduct or something silly and submitting that to anyone who's going to evaluate it, you know, and look at it legally. But what we are doing is we're interested in competing, and we're interested in taking a look at this challenge and divulging answers and, you know, basically ascertaining the answers to the questions. So one of the #1 things to do is to take notes while you go. Now, note-taking is an art, and I'll show you what I mean. Let me share out our Word doc here. All right, so I have a little section here, taking notes, and in here I mention that when you're taking notes, your time codes, or time stamps I should say, should all be coded in accordance with the International de Jure standards. If you're not familiar with the term de jure, it is often used alongside the term de facto, and I'm going to show you what I mean. First off, I can just click that. That's what links do. You can just click them. Well, or not. I thought I could. Oh, there we go. That was a little delayed. All right, let me share my screen now. That just popped up. Do-do-do-do-do. Boop. All right, so hey, look, another wiki page. If you can't tell yet, I like Wikipedia. obviously don't use it in your academic papers or throw it into an APA or MLA reference, but you know, whatever. So, all right, de jure. And if we read the description from Wikipedia, oh, sorry again, it's kind of small. There we go. Let's read the description of de jure. It's an expression that means concerning law, is contrasted with de facto, which means concerning fact. The terms de jure and de facto are used instead of in law and in practice, respectively, when one is describing political or legal situations. Yeah, okay? And of course, as any good Wikipedia article, there's a bunch of other stuff here. Oh, actually, it's not that long. Oh, that's surprising. What about de facto? Is that a long article? Nah, that one's a little longer. All right, all right. Well, anyways, let me just explain what these are all about. All right, it's pretty simple. In the computing realm, let's see, where's the camera here? There we go. In the computing realm, de jure is something that's established by law, meaning that there's actually a prescribed protocol that you're supposed to follow. It's as simple as that. De facto is some guy or gal came up with an awesome way to do something, and other people started doing it, and then other people started doing it, and it became the thing to do, right? So, for example, say at your place of business, or at your school for that matter, if there's a particular way that you're supposed to perform a given task, that would, like, you have to do it that way, that's de jure. And if there's some way that you found from a fellow student is, oh, the way I check the grammar in my documents is I upload it to, what's it, Online Warrior, or one of those silly, like, automatic grammar checking sites, and then I edit the feature in Microsoft Word to check grammar on the fly, and I set it to always check for proper punctuations. You can really tart out those features in Microsoft Word as far as grammar is concerned, by the way. I love that stuff. Anyways, so there's this list, right? And all the students are like, oh, that's cool, let's all do that. But then all of a sudden your professor comes around and says, you're supposed to turn it into turnitin.com, and it does it all for you. That's how you're supposed to do that. So that's the de jure method, and that's basically battling your de facto. So in forensics, the de jure and de facto is basically, a de jure methodology would be like using something like a logical evidence file. A logical evidence file is something that keeps hashes of all the data intact. It's something that's commonly accepted in a courtroom. It's a container for data. It's called a logical evidence file, and it's a file format. You can go look that up. In fact, let's look it up. What am I talking about? Look, I found stuff. Let's see what I found. So we have a Google search here. And we have in-case image file format, forensics wiki. Click. By the way, this is an awesome wiki if you're not familiar with it. I'm going to put this in my notes right now. All right, I put the forensics wiki in there. But the in-case file format, if you're not familiar with in-case, it's one of the industry, it's pretty much the industry standard for forensic investigations. If you go into a courtroom and you have your data saved and you have everything documented by the freaking second for when you touch something and you say, hey, I began parsing the master file table on this NTFS disk at exactly 5:55 a.m. local time when I was sitting in chair B, section row 2. I don't know if chairs are labeled in many facilities, but the idea being you're very specific on what you've done, and you go through and say this is exactly what I've done in the tool, and by the way, I exported my evidence using logical evidence format. If you've used that, that's something that's fairly accepted, and that's something that's considered a little more de jure. This article is boring me. I don't like that article. How about this article? Yeah, I kind of like this one. This actually is, that's pretty dead on right there. I'm just adding this to my notes as I go here. I will make those prettier for when I upload my notes. The final version of our notes. So anyway, that would be the de jure. Everyone does that. It's expected. Well, is it actually de jure? I don't know. That's debatable. Is there a law that says that evidence has to be in that format? No, but precedence has been set in the courtrooms. So if it's just a precedence that's been set, but rather not an outright mandate mandated by law, is that de jure or de facto? I would call it de facto. Someone started doing it. Other people started doing it. The court started accepting it. The court started to expect it. At that point, that's pretty much de facto. Unless there's a law out there that I'm just not familiar with, which could definitely be the case. I don't know. If there is a law that says you need to have that in certain situations for certain digital evidence, well then obviously that would be de jure. So, okay, I digress. So my point was, it's very important that the way you take your notes melds with the way that other people expect to see your notes having been taken. So let me show you some more notes. All right, I also mentioned that you should use a time frame similar to ISO format, International Standards Organization, and your time should be in Universal Coordinated Time, which is UTC. It's I don't remember. I'm not going to attempt the actual pronunciation, but it's another language that swaps the coordinated in time, hence the acronym being flipped there. But anyways, which is Greenwich Mean Time, basically the same thing, by the way. So as an example here, if I'm taking notes on this course right now, I do a lot of forensic collection, if you will, at my work. So when I do that, I need to keep timestamps. I have an example here. There's my example timestamp, and notice that the date portion it fits ISO standard for dates. So we have year, month, day. Now, different regions, different cultures, different countries use different methods for noting time. For example, Britain and the United States use completely different, well, they swap the month and date, whatever. But this is ISO accepted, and also when you're doing sorts in any type of programming language, think about your maximum or value, or at least your most significant bits, right? You have year, month, date, in that order. Most significant, next level, next level. That's by design. That's not a coincidence. That's why it's the ISO format. But anyways, and then I have a little dash or a hyphen here, just because I like those. I like using them. And then I have my time. And time, I always use 24-hour, or if you will, military time. So this is basically 10 p.m., 47 minutes, 53 seconds, and I'm noting that my time is in UTC. So I live in Arizona, and in Arizona, we are always UTC -7. So, for example, right now, I have a script on my computer, and it's like this. Bloop, bam. See that? I'll do it again. And again. And again. So I have a little hotkey that basically just puts this on my screen for me. It's an Apple script that I have bound to a key using Apple services via Automator. I am a keystroke junkie, so if anyone's actually interested in that, I will put the script and the process to do it on Drive. Just make the request, shoot me an email, and I'll add it for everyone, if anyone cares. I have quite a few different keystroke-based macros and stuff that I've written in Apple script. Anyway, not only do I have this version, but I also have this version. And what this version does is these three things here, the wiki version that we use at work, if you put what are those? Single quotes like that, it specifies bold. So this starts the bold and this ends the bold, and then otherwise it just also designates UTC. As opposed to that, which doesn't put it in bold, doesn't have a dash in there, and I love dashes. Remember, hyphens are awesome. And also doesn't specify UTC. Otherwise, now they're the same. So, all right. So my example here. I have an example. What was this, yesterday? Yeah, this is yesterday, midday-ish, it looks like, and an example of taking some notes. Opened evidence exhibit F_trace.pcap in Wireshark version 1.10.2 running under Kali Linux 10 or 1.0.6. Why is this important? We're going to talk about coming up why this is extremely important, but I'm just going to kind of give you a heads up here. Saying something like open the evidence file. What evidence file? In fact, this is also lacking because right here I should have an MD5 sum of whatever I'm looking at. If you're not familiar with hashing, I'm going to save that for session 3. So let me just put a note down here. All right, we'll cover that next time. But yeah, I don't want to jump into more stuff because I've got a full session plan here. Anyway, you want to have the actual MD5 hash that verifies the integrity of the file that you truly did open. Also, saying I opened something in Wireshark, well, what Wireshark? What do you mean, what's Wireshark? Well, Wireshark's that program that started as Ethereal, like back in the day, and then those guys forked it to Wireshark, and that's what I used. Okay. The capabilities and the parsing methodologies that are implemented in Wireshark throughout the years have changed drastically. For that matter, features and functionality of Wireshark change from version to version. And I'm not talking about major version numbers. I'm talking about, for example, 10.1 to 10.2. See, here's the 2 right there. See that? Woo, that guy right there. So if I'm opening up an evidence file, and my version of Wireshark does not have the ability to parse, for example, SMS or MMS, mobile messages, right? I might completely miss something that another analyst might find, say if he or she was just using a more updated version that was capable of decoding those particular protocols. All right. For that matter, you also should put your operating system environment, Kali Linux 1.0.6. Put the exact version. You should hopefully know what OS you're running. And then, for example, instead of saying something like, I took a look at the first TCP stream, right? Well, what did you actually do? Well, you filtered by TCP stream equals 0. That's what you did. So if someone has that packet capture and someone has Wireshark, they could run that exact filter and look at exactly what you were looking at during your investigation. Patrick's typing something. Waiting for a question. All right, so I'll just go for a little bit here until I see his question pop up. So for the workshop, we're not taking notes with this level of detail. Oh, hey, look, cool. I got a question here from Patrick, and the question reads, last session you said the OS X version of Wireshark is terrible. Why is that? You know what? I'm going to show you why. So once again, last session I said the OS X version of Wireshark is terrible. Why? So I'm going to give you a visual. Here's what we're going to do. Hi again. I'm going to share out my entire desktop, which I believe I can do. Let's see if this works. Hey, look at that. All right, and then we're just going to hide that window. Whoop. Well, wait a minute. I need that window. There we go. All right, here's my desktop. So check it out. I'm running OS X. See? Whee! And over here, I have Wireshark. And over here, I have VMware Fusion. I'm going to open VMware Fusion. And I'm going to launch Kali Linux. Oh, I have some other VMs. Go away. Go away. Okay. I'm going to resume the state for Kali Linux, and I'm going to give you a visual in case you forgot of what Wireshark is supposed to look like. For that matter, for those of you who are running Kali now, or as you're following along, I should say, go ahead and open up Wireshark in Kali, or really in any operating system except for in Mac OS X. Don't forget, if you're running as root, you'll get the error that says, hey, you probably shouldn't be, whatever. Go away. All right, I'm going to start a capture here. Let's see. I think ETH1 is where I have all my stuff. Oh, or not. So let's not do that. Let's do something cooler. Let's open a packet capture. See there. Workshop. Level 1 PCAP. Okay, this is Wireshark. So you're probably familiar with what Wireshark's supposed to look like, right? See this? Okay. Let's have some fun. Let's open up the brand spanking new Macintosh version of Wireshark. I click it, and I get this. So first off, what is this? What's going on here? This looks completely different. 100% different. Okay, let's start a capture. So I see my interfaces over here, and I see Wi-Fi. See, Wi-Fi. I'm using Wi-Fi now. So if I click capture, capture, capture. Oh, capture's over here. Okay, if I click Wi-Fi, double click. Where's all my stuff over here? I go to view, toolbars, everything's displayed. Where's all my stuff? What's going on here? All right, let me right click, and then, hey, wait a minute. Oh, follow has a submenu now. Oh, look, and there's nothing there. I can't follow the UDP stream. Why not? I don't know. Because it's the Macintosh version, and it's absolutely horrible. Okay, what about this? Can I follow this? Shows up here. I can follow that. Cool. The show versions show up in a drop-down as opposed to the normal thing you're used to. You can still sort it by conversation size, but you'll notice, like, look, when I click this menu, why is it showing up there? Shouldn't it show up down here? Why is it over here? I don't know. When I click this, why is it up there? I don't know. Anyways, here's another thing. I go to statistics. Protocol hierarchy is not available. Wait, what? Yeah, you can't even use protocol hierarchy, which is my #1 go-to drop-down menu item that we will be covering in this session. Its importance. We're going to go over it. I can't do it in the OS X version. It's horrible. Okay, now, by the way, Patrick et al., that was in reference to the brand new Wireshark version for OS X. That is the developer version from exports. Now, any other OS X version does not run natively using, what is it, Carbon or Cocoa? I can't remember the name of the current GUI that uses the Quartz engine on OS X to draw a pretty GUI. So, yeah, Patrick just says that he has Xquartz and it looks like other versions. Seems pretty good. Yeah, it did seem pretty good. The problem was, A, getting Xquartz to run, which for most people isn't that big of an issue. But B, it looked great, and then all of a sudden, what did they do? They switched to this filth. Why? I don't know. I have no idea. They just decided, hey, let's make it different. You know, because you fix what's not broken type of thing. You know, I don't know. So, all right, they were trying to get rid of the Xquartz dependency, obviously, and whoever was in charge of the GUI just decided to do things quite differently. So, anyways, hopefully that answers your question. Your little smiley face in chat there. Yeah, I'm not a fan, obviously, as you can tell. Okay, let's see what's up next on our agenda. Oh, we're still on note-taking. So you might be thinking, why are you spending like 20 minutes on note-taking? Why are you doing that? There's a reason. So if you're using Kali Linux, well, let me back up 2 seconds here. I prefer very low overhead text editors that have very powerful functions. For example, I need to do a find and replace and be able to use grep-like functions, or literally, you know, regular expressions. So if I use something like Word, I mean, how much memory is Word taking up, and how slow is Word when it comes to just quickly finding and replacing in a very large data set? You ever tried to open a 1,000-page document in Word? Yeah, right? No thanks. No problem, Patrick. So here's some examples. First up, if you're using Kali Linux, let me share out my screen here. Where'd it go? There it is. Share that out. There we go. All right, if you're using Kali Linux, there's an awesome little tool called Keep Note. And again, that's Keep Note, K-E-E-P-N-O-T-E. It is included with Kali. You just run it. Bam, check that out. Oh, let me get rid of this. Go away. All right, I'll leave you in the trash for now. No, I won't. I can't have something in my trash. The trash has to be empty. It's just a thing. I can't have something in the trash. All right. Anyways, in Keep Note, you can organize your stuff really, really easily by, for example, going to File, New Notebook. And then what do I want my notebook name to be? Well, you'll notice here I misspelled notes when I created it yesterday. Maybe I was in a hurry. I don't know. Let's do something different. We have workshop as a folder I have. Make something in here called notes, and then use that. Oh, just notes for now. Well, no, I can't do that. CSUF reference workshop notes section 2. There we go. So I now have a new folder, right, for my notes. I go to new page, file, new page, and miscellaneous, and then hi. I can type notes in here. Yay me. So I like to use this type of tool. You can continually create pages like OSX commands and how to curl a file via Tor. And then where do I have that? I have that somewhere. Documents, technical, OSX, curl via Tor. I already have it ready to go. Oh, sorry, that was in my other operating system. Anyways, so there. Now I have my notes taken. So how do you curl a file via Tor on Mac OS X? Well, that's how I do it. So don't. By the way, please do not. In fact, don't look at this. That's bad. That's very, very bad. That has some really bad malware. Don't go to that link. Please don't go to that link. You know what? Let's just do this. Gone. Don't go there. You should put an annotation over the YouTube video so no one tries to type that in. That is active, really bad exploit kit-based cryptolocker malware. Don't go there. Okay. Anyways, so this is a pretty cool program, but let's check out some other stuff. Oh, I'm sorry. By the way, keep note. If I just do a Google search here for keep note, you'll notice that this program is multi-platform. Hey, it's Windows, Linux, and Mac OS. Yay! Also, please note that you can include pictures. Yeah, check that out. Yeah. So, anyways, oh, and by the way, on the back end, it's all like XML, easy to parse out. If you ever switch to another program, you can write your own parser, or probably just find something that'll import it, and it's not necessarily only usable by that particular application. The XML just tells where the document structures are, but it's literally saved as an HTML file. So, I mean, ridiculously easy to port your notes over. Okay, so enough about KeepNote. Another program that you might already be familiar with that I highly recommend, and these are not paid advertisements, people. I'm just showing you what works for me. Is a program called Evernote. I have Evernote on my cell phone. I have an Android. I have it on my Macintosh computer. I have it on a couple of my different VMs. I have it on my, well, that's pretty much the gist of where I have it, actually. But, oh, I have it on my wife's phone also, and I have an account on her phone along with her own account on her phone. So you can organize all your stuff, and it just synchronizes across your devices. I mean, you can't beat that. It's really nice having notes available cross-platform. Evernote is very simple to keep note. I'm not going to execute it. In fact, I don't think I even installed it. I didn't. So, yeah. But just heads up, it's out there. Okay, so, oh, also Linux-based. There's a client out for that too. All right, and I also mentioned in the Word doc that we have other cool stuff like Notepad and Text Wrangler. So let me do something here. I'm going to share out my primary desktop again. Bum, 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 bum. Screen 1. Yeah. All right, there you go. Hide that, close that. Okay, you'll notice over here on the bar on the right-hand side, look over here. Woo! I have something called Text Wrangler. I also have something called Sublime Text, but that's shareware, and it pops up often asking me for money, so I feel bad since I have not paid for it. I don't like it enough to pay for it, so we're just going to use Text Wrangler. I click on Text Wrangler. Whoops, ignore that. Heck, now I have to see what was on that screen. I'm going to have to cut that part of the video. Whoops. Anyways, as you saw on the other screen, it's just a text editor. But it also has some really cool features. For example, it's very good at editing different languages. It's also one that has built-in terminal bash stuff, which is nice. Here's AppleScript, like I wrote these in. So it integrates with that and has a full-on dictionary. And it has all these cool features under the text menu. Oh, I like those. So here's one thing, right? Let's just say I want to do a find replace. I want to replace space dash space. I want to replace it with something. Here's grep. I can use grep commands now. Yeah. Digits. I want to replace digits. Anyways. So it works really well. I highly recommend it. And if you're running a PC, I recommend using Notepad++. I don't think I have a Notepad++ installer on Google Drive, but I'll put it on there. So let me put a note here to myself to do that. Notepad++ installer. I'll put that on there, or just Google it. Right, just Google it, that's what we do. Okay, so enough about note-taking for right now. Okay, now I'd like to talk about, just in general, how do you hone your skills when engaging in, well, let me back up. How do you hone your skills? You hone your skills by engaging. You have to remain active. You have to keep an open eye on different research, different articles. So one of the best ways to do that is to compete in challenges or competitions. If you come in very, very last place in something like a capture the flag tournament, you still are going to learn so much more than you would have if you didn't spend that 24 hours just completely zoned in and using all these tools that you've never even heard of and attempting things you've never thought to attempt. So in this class we have the challenge, right? So part of this challenge, this isn't a competition here, it's just a workshop, we're having fun. It's funsies, right? Yay! So when you're doing something like a challenge, you open up, in our case, a packet capture, and you look at it, and you're thinking to yourself, well, there's a lot of stuff in here. I have no idea what I'm looking at. So how do you find information? Well, I'm going to show you coming up here shortly how to find information. We're going to go through level 1 and 2. But at the same time, everything you test, it's like the scientific method, right? Everything you test, whether it's successful or not, you're learning from it. Especially in competitions, you will also play with other people or against other people. And regardless, you're going to learn a lot. So if you're not familiar, there's two major types of competitions that kind of float around, at least like the DEF CON security conference scene. One is called Capture the Flag, and another one is called Capture the Packet, or sometimes it's called Find the Packet, something with the packet in it. So what we're doing is more of Find the Packet, Capture the Packet type of thing. But the Capture the Flag is like a penetration testing type of thing where you have a server and you try to protect it, and another person has a server and you try to get into it. So the blue team protects your server, the red team attacks the other person's server. So as you're going through these types of competitions, you learn so much. When I was at DEF CON 22 this year, what, 2 weeks ago? What day is this? Where am I? I don't know. Yeah, I think it was 2 weeks, 3 weeks ago. When I was there, I competed in a forensic challenge, and I learned how to use over 5 different tools that I had never even heard of. Never knew they even existed. At this point now, I know how to decrypt an iPhone backup on the latest iOS. Cool. What if that fails? Well, I know how to write a custom parser to make it work because the current tool available to decrypt iOS-based backups, iPhone, iPod, whatever, works with iOS up to version 5. But if you just make a minor edit and patch the program, it'll work with the current versions. Ah, why would I know that? I didn't know anything about that. As far as forensics and iPhones or iDevices, is concerned, I just knew that you jailbroke the darn thing and ran certain programs. But what if you don't have the phone? You have a backup. Well, I'd never run across that, but now I know how to do it. Yay! I also learned how to do really cool things, like I learned how to write some Perl script. Perl code. I'm going to call it Perl code. I am not advocating Perl in any way, shape, or form. No. But I have an old Perl guy on our team who was like, oh, just do this. And it was beyond elegant. So anyways, I took a bunch of notes and I learned about that. And I'll digress at this point. I've learned so much just competing in this challenge at the security conference. So what we're doing right now is I'm just showing you in an academic environment, you just play around, you look for stuff. When it's a competition, it may feel like it's more pressure, obviously, right? Your temperature starts to rise and your blood's boiling, but the thing is it's all about fun, it's all about networking, and it's all about learning. You learn more as a kinesthetic learner when it comes to forensics, let alone any other security science. It's a science, not an art. So, for example, when you do a hands-on experiment, you really learn what works and what doesn't work. I mean, I could read all these books over here in the bookshelf, and I have because I love books. Oh, goodness. But you're not going to learn unless you get your hands on a keyboard. So, another thing about competitions and competing is the camaraderie, and for that matter, the relationships that you build. When I came home from DEF CON this year, I had a stack, I don't know how big it was, of business cards. Really, I had a stack of business cards this big, let me see, yeah, about that big, that just kind of went over into the pile, which is the recycle bin. But I had a stack that was not even big enough to show you with my fingers, but I had about 5 cards of people that I've developed and formed really good relationships with that I will maintain as long as humanly possible. Part of interacting with people is learning what they know and being able to teach them. The security industry specifically, especially the forensic realm, it's a very tight-knit, small community. Even if you say you have 100,000 people, that's nothing, right? And there's not 100 forensics. I would doubt it. And again, maybe that's a close number. I don't know. I made that up. So when you learn these new techniques, you meet these new people, you do it all by just simply entering a competition. You come in last place, whatever. You compete, you show your yearn to learn, your want, you put your name in the hat, so to say, right? So, all right, I'll digress at this point, but no, I lied, I won't digress. One more thing. So, one of the guys at my work created a script. Well, it's a program, it's not just a script, but created a utility, if you will, to pull out a lot of different artifacts related to live response for OS X, up to the newest versions of OS X. So live response deals with pulling data like active memory, like all the memory, page file stuff that's volatile that can be deleted if the computer's turned off. Well, page file will be resident, whatever. Currently running processes, currently open programs, currently open network ports, currently open networking programs, and blah, 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 blah. So if the computer is shut down, what are you going to lose? Live response deals with grabbing that information and saving it. And if you've ever heard of something like volatility that'll actually parse through and has many plugins and modules to run against a memory image, that's kind of the idea. So anyways, we have this particular script, this utility written up, but what we don't have is that's for live response. What we don't have is just long-term persistence type of stuff. In OS X, almost everything is stored in a P list. It's called just the letter P, as in Papa, and then list. Just look that up. Or no, I'll put a note here. I'll put some links to plist stuff, plist OS X. So our utility is all about live memory. But what we don't have, so we have the live memory stuff. What we don't have is the stuff on the hard drive. Well, I met a guy at DEF CON by doing this competition that I did who has the exact opposite. What he has is if malware comes onto a Macintosh computer, like malware on a Mac, that's impossible. No, it's not, trust me. So if malware comes on, his stuff will find out exactly how it got there in the first place. Our stuff finds out what it's doing. You put it together, right? You know what I'm saying? So we're going to have an amazing utility when we pool our knowledge. And how did I make that contact? Well, I put my name in the hat, and I competed. Our team happened to win, by the way. But that doesn't matter. The idea is that when you compete in these things, you form relationships, you learn a lot, and you take away so much more than you're putting in for just the 6 hours, 8 hours, even if it's a 4-day straight competition. All right, enough of that. So I'm going to go back to our Word doc here, and it looks like we are just at, yes, test, test, and test again. In the forensic realm, you should never rely on the results from one tool. Why? I'll show you why. In your Word document, I have a link. And we're going to pull this link up right now, and let me share it out. Here we go. All right. This is on a website called digital-detective.net. Let me zoom in there. All right. And it's called Digital Evidence Discrepancies in the Casey Anthony Trial. I mentioned earlier, even before session 1, that if you get a bit squeamish about odd topics, that you should let me know. No one let me know, by the way, which is a good thing. So I'm not going to discuss the specifics of the Casey Anthony trial because I sure as heck don't want to touch that. But I do need to talk about this particular portion of the trial. So, Digital Detective, before I read this article, one really good thing to do whenever you're reading any type of forensic article from a source is to find out, well, who the heck is that source? So, let's go over here first. I'm just going to go to the web page, to the home page, if you will, for Digital Detective. So, what is this? First thing that pops up, they make digital forensic software. Okay, cool. What else do they do? Opera, Firefox, IE, Safari, Chrome. Okay. What am I looking at here? Oh, they do browser forensics. Cool. Now, I already knew that because otherwise I wouldn't be showing you this article, but I'm just pretending, right? Oh, okay, they do that. Cool. What else do they do? Advanced okay, now I'm getting bored. Anyways, here, let's focus on this right here. They do browser forensics. For example, they have a product. If I go to products, you see this little guy right here called Net Analysis. If you've never heard of Net Analysis, you'll want to take a look at it because it's pretty freaking awesome. I'm going to add it actually to our notes. Okay, I've added a note to our notes to take note of this page. Anyways, so what does Net Analysis do? Ooh, it's the industry's leading software for the extract internet browsers. Cool. I'm going to stop right there. This company has an agenda. What is their agenda? To sell their product, obviously. So let's go back to this article now. Who's it written by? Craig Wilson. Who's that? I don't know. Let's find out. Let's see. It doesn't have a bio. Well, that's cool. So let's dox him. Digital Detective, Craig Wilson. He's on the executive team. Look at that. Well, he hasn't written a bio. Okay, well, I just found his bio, so that's cool. By the way, that's how you use Google, right? Authored by Craig Wilson. No bio available. All right, Google it. Oh, look, there's his bio, right? On his own page, so whatever. 18 years of law enforcement, or LE, with some police, and he's been involved in digital forensics since 1999. All right, what? 1999? What were you doing in 1999? I can tell you what I was doing in 1999, and it sure as heck wasn't digital forensics. Anyways, all right, he is also a digital forensic research scientist, and wait for it, he's the author of the forensic software tools Net Analysis and some other stuff I don't care about right now. So we just found out this is a long-term guy in the field who has a bunch of acronyms after his name. That's cool. And he wrote the tool. He wrote the tool that we found here that the company purports to make, that purports to be the industry-leading software in extraction and analysis of data from internet browsers. Okay, now we'll go back to the article. Well, not that. Go away. Now we'll go back to the article and take a look. Alrighty, so here in the article he says, I don't want to talk too much about the murder trial because it was a pretty messed up trial. And okay, here we go. This is so important, I'm just going to read this paragraph. We're going to do a little reader's theater here, if you will. So I'm reading, starting here. The digital forensic evidence in the case of is particular. Let me learn to read. Let me try that again. Reading is hard. The digital forensic evidence in this case is of particular interest to me as it involved the recovery and analysis of a Mozilla Firefox history database. All right, let me just highlight that and let's pause. In the chat room, for the three of you in there, if you've ever analyzed a Mozilla Firefox history database, put something in the chat that says whether you've done that or not. I've done that before, and I can tell you it's a bit of a pain in the butt. He's going to go on to describe why it's a pain in the butt. But I'd rather keep reading this paragraph because you're going to start to see the importance of why we're covering this article. Starting here. The internet history records within this database turned out to be extremely important to the prosecution case, as the existence of Google searches related to chloroform and other possibly relevant records prior to the child's disappearance could have indicated premeditation. All right, I'm going to focus on this. This is just me, so again, I don't want to start a war or an argument here. Could have indicated premeditation. Yeah. Okay. Could have? Are you sure about that could have thing? So I'm going to go more along the lines of if I have traces of chloroform in someone's car and I see Google searches for how to make chloroform and all of a sudden their child disappears, yeah. Could have indicated? Okay, whatever. Anyways. This, of course, could have meant the difference between a conviction for murder in the first degree and manslaughter if found guilty. So premeditation, for those of you that are not, I'm pretty sure everyone's familiar with it, but I just need to make this clear. This is a this is a huge thing for this case. Premeditated murder is different than murder. If I am in a car accident and my child's in the back seat and I absolutely lose my mind and wig out because my daughter's life was put in danger because of some other idiot running a red light, and I jump out of my car and I engage in fisticuffs with the other driver and one of us dies, that is not premeditated murder. That is in the heat of the moment. Sounds like two idiots. I mean, that's probably not uncommon actually, but it's not, I didn't think it through, it just happened, right? So that's a lot different than we get in a car accident, my insurance sues the other person, I find out who that person is, what that person's name is, I start to dox them online. Doxing, by the way, just means it's short for document, so kind of like what I did with the Craig, who wrote the article. Just quickly look them up, and there's different ways to do that, by the way. I might cover that in some other session. Nah, not really. But anyways, I look him up, I find out where he lives, I start watching him, I start getting obsessed with the guy, and then eventually I murder the guy. That is completely premeditated, right? Especially if I plan the entire thing out. So in this case, what they were trying to do is they were trying to look, in fact, here, next paragraph down, they were trying to look on Anthony's computer, and they're looking for things like a hit to the word chloroform. Let me give you an example. Here's a browser. Here's the word chloroform. Here's the wiki article for chloroform. I now have multiple forensically... Well, I was going to make up a word there. Let me not make up a word. I have multiple artifacts, forensic artifacts is what I'm trying to say, on my computer now that I've visited this web page. This class is not going to go into computer forensics, so we're not going to talk about that. But I mean, obviously, the most basic one. Wait, I almost showed you my internet history. Oh my goodness, no. Who knows what's in there? Anyways, the most basic would be my internet history. Jeez, I'm going to have to edit this video twice now. Oh my goodness. All right. Anyways, so the article goes on to say the hit was identified in what is referred to as a MORC database. The file was identified as residing in unallocated clusters, and rather surprisingly, is reported to have been intact. Alright, so if you're not familiar with unallocated clusters, we're going to basically just state that it's something that's most likely been deleted from a computer. We're not going to touch computer forensics, so I'm not going to go into exactly what that is. But it's not common to find an intact file, entire file, in unallocated. Unallocated means I've overwritten it, I've deleted it, but not overwritten it. It's not super common. So the author goes on to explain what a MORC database is. Right? So here's what the database is. forensic analysis. And then look, hey, he's using UTC, Universal Coordinated Time, like I was talking about earlier. And here is where it gets interesting. It is a matter of record that our software net analysis version 1.37, notice he includes a version number, there's a reason for that, was used during the initial examination of this data, and then at a later stage, another tool was used. This, of course, good forensic practice, often referred to as dual tool verification. All right. I don't think I was aware of that word. At least I forgot it since I read the article. So here, I put it in our notes. Dual tool verification. I wouldn't use the. I don't like that actually. Dual. I want it like triple or quad or something. So anyway. Alrighty. So check this out right here. Here's what I'm talking about. We'll wrap this part up. You're probably wondering why I'm taking so long here. There's a reason though. In this older version, there was no option to present the timestamp as a local value adjusted for daylight savings time. In forensics, it's all about time. It's all about chronological order. It's all about what occurred first, next, and subsequent to that. And it's all about, yeah, time. I can't stress that enough. Anyways, this changed in Net Analysis version 1.50 when a further date column was introduced which presented the examiner with UTC and local times adjusted for DST. Alright, so now what I'm going to do is just skip ahead here and give you, this is telling you like, look, this version did not have the same feature that this version had. This version was used. Okay, what else we have? Discrepancies. Ruh-roh. During testimony, I'm reading from here, the defense picked up on the fact that there were some major differences in the results produced by both tools. The defense assertion was that the initial results produced by net analysis were in fact correct, and that the results from the second tool were flawed. Whoops. All right, and then here's the main thing, right? So website about chloroform analysis, the second program showed 84 hits. 84. Okay. Their tool, the net analysis, showed how many? One hit. One visit to a site about chloroform. Second tool showed 84 hits to a site about chloroform. That is a major discrepancy. Now, let's think about this from what I would consider a logical perspective, not a courtroom perspective, because that stuff is not logical to me at all. If I think that someone used chloroform in the process to murder someone, and I find one hit to chloroform on that person's computer, especially based on the timeline, because that's very important, I look and I see that they looked up chloroform, I find traces of chloroform in their car, and all of a sudden their child is missing. I'm going to put two and two together. Now, what's the difference between one hit to chloroform and 84 hits? I'll leave that to you for debate. I think going to a page one time, you could print it out, you can review it, save it as PDF, you can just read it and remember what you've read, you can write it down. Why does it matter that she has to go there 84 times? It doesn't matter. What does matter is that when you're in court, if you present evidence and your evidence has a glaring discrepancy, what they do is they completely throw out everything that you're bringing to the table. They're going to, hold on, I want to go off on a little tirade here. By the way, the article goes on to show you exactly how everything is parsed, and he goes on to essentially point out why his tool is correct. Which is awesome. I like that he did this. I mean, he should have. I like that he did this, but look how he ends this. There are a number of conclusions to be drawn from the digital evidence presented in the trial. However, I will leave this to the members of the digital forensics community. He's being cute right here. He basically proves in this article, like, hey, those other guys are idiots. My tool works great. Shouldn't have used that other tool. Good luck. But what he says is, well, I'll let everyone else decide. That's cute. And then he says, forensic tool validation is certainly at the forefront of our thoughts. All right, now let me go off of my little tirade to end this little charade here. Okay, why is it important? Why is this important? Why did I just spend 15 minutes, whatever that was, talking about this little article? Well, if you're in a courtroom and you present data with a discrepancy that big, they're going to question your entire forensic process, everything that you have done. All right. Now that's more computer forensics that the article deals with, but it's the exact same realm in general, right? We're using forensic tools. The version of Wireshark I'm using might be different than the one you're using. The version of blah 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 might be different than the version you're using. Heck, I showed you guys you can use Text Wrangler to do a find replace and use grep, right? Maybe a version of Text Wrangler has a bug where it doesn't do a find replace appropriately, and I'm doing a find replace to obfuscate the name of a witness in a trial, and one of the names does not get obfuscated. You know, I don't change the person's actual name to like Bob or something, and all of a sudden his real name is now a court record when it shouldn't be, or whatever. So anyways, when your entire process is put under the gun, and the only thing you can say is, well, one of them is probably right. Good luck with that. They're going to take every bit of digital evidence you provided and toss it right out the window. Which, by the way, if you look more into this case, you'll see that digital evidence, yeah, that it really hurt the trial. So, enough of that for now. Okay, so that was the article was to push the whole dual tool verification, apparently is the correct term. But yeah, different tools. If you get different results, why? Find out why. And if you use 3 tools and 2 of them present the same data and one seems pretty wonky, I would just ignore that third one and like not present it. You know, that doesn't exist. All right, now we're going to talk about reviewing packet captures. We're going to kind of switch it up. With last session and this session, we're pretty much doing kind of like methodology stuff and then hands-on for the second portion. So let me share out the Microsoft Word file. Is that it? Yep. Hey! Okay, we're going to talk about packet capture review tips. So one of the first things I ever do when reviewing a packet capture is I go to statistics. There is a menu, an entire menu devoted to statistics. There is a reason for that. That is not just like, oh, hey, you know, let's put a statistics menu in there because it's cool. No, it's because it's vital. Taking a drink, one moment. Okay, I cannot stress how important statistics are. The best way that I can stress it is to show you. So we are going to cover the statistics menu for the level 1 PCAP. So I would like everyone who's following along, whether it's post-recorded session or Patrick, Ivan, and Brian or whoever's grandmother, I want you to open Wireshark and open the level 1 PCAP. I am going to share out my screen and do that now. I like how when I share screens, I have to swap back to me, so you keep seeing me like looking over here. It's kind of silly, but whatever. All right, here's my Kali Linux. I'm going to put in my long password. Hey, all right. Okay, now level 1 PCAP. Cool. There's my PCAP. Now, I have the packet capture loaded. My screen is shared out appropriately. And for those of you in the chat room, just pop a little thing if you're able to literally follow along now. If you're just gonna do it later, that's fine too. Just you know, I'm gonna go over it. So we have menus. One of them is called statistics, an entire menu for statistics. So we're gonna cover each of these guys here. Well, we're not gonna cover packet lengths because I don't like that one, but we're gonna cover the rest of them. The first one in here is summary. I choose summary. What do I get? I get a summary of the capture. Starts off with the file section up here. Can I highlight this? No, but I can copy it. Oh, I thought I can copy it. Maybe not so much. Oh no, it's the next one I can copy. Oh, whatever. All right, so I have where the file resides, how big the file is, the format, The encapsulation, these are Ethernet frames. The packet size limit, 65,535. There's a reason for that packet limit, by the way. Look that up. Time. When did it start? When did it end? And how long elapsed, or how much time elapsed during the capture? And then down here under display, this is my current display. What am I looking at right now? This is very, very helpful for when you run some type of filter, but you want to prove exactly what you're looking at, what's being filtered out and what's not being filtered out. So if you see down here, I have no filter, ignored packets, 0. And then as such, I have all these packets being shown, and I have some averages, calculations, and all that. Let's mix it up a bit. I'm going to type in http.request.method=get. Right? http.request.method=get. I'm looking for HTTP GET requests, meaning I'm looking for websites that were visited. And I hit return. Now I have a different view. I'm seeing only GET requests. See, these are all gets. Get. So I go up here to statistics and I go back to summary. Display filter. Now I have a display filter. How many packets are in this bad boy? 20,890. How many are currently displayed? 824. What percentage of the entire capture is that? It's less than 4%. So you see here, you can use this, especially for forensically proving what you have done. Well, that didn't make sense, but you know what I'm saying. To prove what you've done in your forensic analysis. Let's go with that. I like that more. So you can just take a little screenshot of this guy right here and it's like, yeah, that's what I used, and here's what the result was. This is easier to get across your point than this, saying, hey, look, I did a, down here, by the way, down here, see this right here at the bottom? Packets displayed. That's it. That's all you get. Can I right-click that? Do anything? No. I can do this, but that's boring. So, yeah, all right, cool. Let me clear that filter. You know what? By the way, you can save your filters. I don't think I mentioned this last time. If I want to save this filter, I just click Save, and then I give it a name. Save filter as GET requests. Bam. I can clear it to bring it right back. I can change GET to POST. Now I'm only looking at POST requests, and I can save that. POST requests. And I can alternate GET requests, POST requests, GET requests, POST requests. Ah, ooh, it's cool. All right, sorry. I like that feature. Anyway, what's next under statistics? We have comments summary. Well, yeah, I don't have any comments on here, so meh. Really just the same stuff that you're going to have in the initial summary, because I don't have comments added. You can add comments. I'm not going to touch that for now, though. Next up, show address resolution. This is vital to any investigation, especially if you're dealing with malicious software. Host information and Wireshark. So Wireshark is able to actively look up different hosts. Okay? So it sees traffic from this IP, 69.58.188.49, and it has resolved it to mzl.la. Okay. If I scroll down, there's some Imgur, Zazzle. Zazzle's in there. What else do we have in here? Bunch of content delivery network stuff. Look at all this. Akamai is a content delivery network. Their one also. Their one too. Yeah, it's all CDN stuff. That's boring. Hey, Daily Tees. I love their stuff. Well, I like nerdy T-shirts, which you probably already noticed. Oh, there we go. Meme generator. Yeah. All right. I'll digress. The idea here is when you are looking at an address name here, right? It's going to have a lot of IP addresses. But you can just go up here, stats, show address resolution, say, hey, what have you actively converted? The reason this is important, for example, for malware is, let's say I have malware that replaces that Google Plus associated IP with an attacker's domain name. it might show up there. Now, you may not necessarily recognize that that's happened, but in your investigation at some point, when you go run something like a whois on this IP address, oops, it's using the keyboard. When you run a whois on this to see who it's registered to, you get back Google. And you'd be like, wait a minute. If Google owns it, why over here did it resolve to, ignore me.notanattacker.ru? Like, why did it do that? Or for that matter, if I do a dig-x on it and do plus short, right, it comes back to that. Well, that's what it's coming to now. Okay. So, but it's not coming back to that Russian website, so why'd that happen? And it could be because the malware actually did that, but I'll digress on that point. Okay. Next up, we start to get into the real important stuff. So these guys right here, these three are critical to any packet capture evaluation, especially, for example, what we're going to get into right now. Okay, so we have half an hour left. We're going to go through level 1 and level 2. How are we going to start level 1? Well, we're going to use statistics. Protocol hierarchy. This gives you a breakdown, like I talked about last time. This gives you a breakdown of all the different protocols along with the number of packets and the percentage thereof, the byte count and transfer rates, and some other statistics. I don't care about the ones at the end much. Okay, so in here we see some stuff. Now, for me, what pops out the most to me? Syslog pops out. If you're not familiar with syslog, it's the system logging mechanism. I want to find out, like, what did syslog capture? So I right-click, apply as filter, selected. See, it's easy. Just right-click, apply as filter, select. I have some syslog stuff. Right-click. Oh, by the way, here's what it does for me. Syslog and UDP and IP and Ethernet and frame. Okay, sure. I'm pretty sure we could just search for syslog and, yeah, find the exact same thing, but whatever. So, yeah, filters are pretty easy. They don't have to be complicated. See, protocol is syslog, so just type it in. Anyways, right-click, follow UDP stream. And I have all this stuff. What is this? These are system logs. If you work in a security operations center like I do, this is what you look at all freaking day long. All right, so I see that on the domain, well, actually, account domain, that's the workstation, fox-ws. We have a computer name now. Cool. What happened? A process was started. Cool. What process? The new process name was firefox.exe. Where did it run from? It ran from that directory. Cool. Anyways, that's pretty much how that works. Fairly simple. I'm not going to get into reading logs. I almost did that. I'm going to digress here and close that. All right, so we didn't find anything super awesome about that syslog, so let's go back to the protocol hierarchy. What else do we see in here? Well, the next thing that stands out to me is Internet Relay Chat, which just so happens to be the answer to our round 1. So let me mark this. We're at, I'm going to call it 9:22-ish. 9:22 of the video. Oh. It's not the video, that's time-wise. Oh, like an hour and 22 minutes. Okay. Other stuff that stands out, we're going to pretend like that's not where the answer is, okay? Other stuff that stands out. Well, those are the two that are like obvious to me, like, hey, look at me, something's going on here. JavaScript object notation, JSON stuff, typically has some really good stuff in it. JSON is used to return stuff from a server. So when a user is entering stuff and the server sends back a response with a bunch of cool info, that's usually in those objects. More about that later. And of course, SMB is used for file transfer in Windows and other OSs. But anyway, all right, before I go into that IRC traffic, I want to finish this stats stuff. I have 2 more to go over, and then we'll just solve level 1, okay? So conversations and endpoints are very similar. I'm going to go to endpoints first. If I open up endpoints, it shows me what hosts are involved in this entire packet capture. I have a Netgear, I have multicast, I have some Dell device, my broadcast, so these aren't devices, these are communication channels. Some Cisco device, a Hewlett-Packard device, which by the way has quite a few packets in here. Notice that we have the Hewlett-Packard and Dell computer. Add the number of packets they have together, you get the number you have from Cisco. So that probably tells you that Cisco is the switch or the router or whatever, and that these guys are the ones communicating. You also have whatever that Dell computer is. I don't know why you're there. What are you doing? Let's filter on that. Oh, it's just doing DHCP. So notice that it does an Ethernet address equals, and it actually puts the MAC address in there, so you can filter that way. And this is basically just DHCP requests. So in other words, this isn't really involved in our traffic. Let's go back to endpoints. So just from viewing endpoints, I already know what I care about. I care about that computer and that computer. What's in the middle of them? That guy. How do I know that? Well, I'm assuming that. I don't know that, but I'm assuming it because I noticed 9 plus 11 is 20. And then I took these numbers and added them in my head and said, hey, look at that. It's all the packets. They went through that guy. So pretty easy. I can also go over here to other tabs, like IPv4. These are hosts on the Ethernet network. These are any IPv4 hosts that were involved in any way, shape, or form. All right, so I can sort these. I can sort it by address. I can sort it by bytes. When you're looking through a packet capture and you want to know who sent a bunch of stuff, go to bytes. When you look at the number of bytes, you can see who transferred the most data. So who transferred the most data? These two, which, by the way, is also our answer to level 1. This right here, we will help you derive the answer to this. So we have two local devices, 172.29. Oh, those aren't local, sorry. 172.29.1.50 and then .55. See these guys right here? Those are very important. Why? The number of bytes they've transferred happens to be fairly high. They also happen to be the answer to what we're going to go over here. But you might just get a clue that that's the case by looking at this. And then we have TCP hosts that are involved, and so you have over here a bunch of external stuff, and it shows the port numbers, possible resolutions to those port numbers also. All right, now not only do we have the endpoints, but we have conversations. This means conversations between endpoints. So we go back to Ethernet, right? And we have the Hewlett-Packard communicated with the Cisco device. The Dell communicated with the Cisco device. That tells us something. That kind of furthers when we were looking at endpoints and we saw these two guys and we thought that they were involved in communication through the Cisco. Well, this proves it. That communicated with that, and that communicated with that. Cool. We can also go over here to IPv4 and we can communication inbound and outbound. So I can see, let me sort, and let's see, are there any, not really. Yeah, they chose this 172.29 for this capture. But anyways, I can see that, like, for example, see here we have the 55 is involved and a lot of external communications, as is the 50 active that are going outward, hitting all these other addresses. You can also turn off name resolution, by the way. So instead of, see over here, there we go. So right now I'm looking at name resolution, and so the MAC address typically had the 6 different sets of 2 hex values, right? So the first 3 often refer to the company. Now if I turn that off, I get the full MAC address. These are the MAC addresses. However, 000874 resolves to Dell. That's their MAC address. So I'll put a note in here to talk about, to give you a link on MAC address lookup. Media access code lookup stuff. Okay, that's enough of that. So level 1, how do we solve this? Well, check it out. The first thing I would do is I would go to protocol hierarchy, and the first thing to me that pops out is the internet relay chat right here. So I filter on it, right click, apply as filter, selected. And I see this, request for private message, response, 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 ping, ping, pong, IRC does a lot of ping-ponging and making sure the suckers are still there. What are they using? SwiftIRC.net. How do I evaluate this traffic? Well, right-click, follow TCP stream. When you do this, you get this. What is this? Private message in the chat room, secret spot. Hi, Greg. And then death merchant, private messages, secret spot. When you see pound and a name like that, it's actually a channel, meaning a room. Which, by the way, let me in the Word document, I put a little note here that shows you what IRC is. And I don't want to go too far into it now. If you're not familiar with the Internet Relay Chat, it was one of the original protocols of the Internet, pretty much. You had the World Wide Web running on HTTP. You had FTP, Telnet, Gopher. If everyone here is familiar with Gopher, yeah. Newsgroups, and then you had IRC. IRC was the primary way to chat, like real-time chat, kind of like we're doing over here in Skype. See? This exists because IRC existed. IRC paved the way, is what I wanted to say. There we go. So, IRC, unless you were in some AOL chat room, you were using IRC to communicate. All right, anyways, so when we look at this traffic here, what are we looking at? This looks weird to me. Here's what does not look weird. That doesn't look weird. Private message to a room, to a channel called secret spot. IRC rooms start with a pound, by the way, or an octothorpe if you want to. It's a funny name for the octothorpe. What? Yeah, so in the channel it says, hi, Greg. And the response is, hi, Betty. And then Death Merchant says, what day do you want to meet up? And then we have some ping-ponging going on. They are currently connected to a server on hades.de.eu.swiftirc.net. So, and then we have a private message. So in the channel, so in the public chat room, which is probably still private though, they have communications. Hey, Greg. Hey, Betty. When do you want to meet? And then all of a sudden we have a private message. And this private message here, oh no, this still goes to the room, I'm sorry. Yep, still goes to the room. But all of a sudden we have that. What the heck is that? Is that normal? I can tell you now it's not normal. But let's see what else we have. We have another, okay, so Death Merchant responds private message with that. What the heck's that? And then another private message, and then one last private message. Awesome. What is all this? One thing you can do down here at the bottom, check it out, you can sort by the entire conversation or individual sides of the conversation. So here's one side, blue, or excuse me, red, and then the other side, blue. In this, we want the entire conversation, and we want to save it. We leave it on raw down here, and just hit save as. Desktop. Stuff. No, let's change that. IRC chat. Save it. And we can go evaluate it outside of Wireshark. I'm going to open it with LeafPad. I don't care what you open it with, just open it with something. And in here, I'm going to cut out the stuff I don't care about. So I know it. Hi, Greg. Hi, Betty. I don't care about that. Go away. What I do care about are these 4 different private messages. Now, these messages seem to be encoded. So I'm going to get rid of everything up to the encoded. Bam. Those are 4 different lines, 4 different messages. Save my file, IRC chat. I need to decode this. In the Microsoft Word document that I provided you guys, I mentioned that when you have traffic and you don't know if it's normal, you can set up a lab environment. So I'm not going to go through the entire lab environment because the purpose of today was to get a lot of theory out there and then go through some hands-on stuff with decoding. I don't necessarily want to go through creating an IRC server. However, I do have notes for it in the Word doc. So what I've done is I basically installed something called IRCD, which is an Internet Relay Chat server, and I also installed XChat, so which is a client, by the way. So I'm going to use those. What I want to do is I want to replicate IRC traffic. How do I do that? Well, I go over here, IRCD hybrid. I can't run it as root. Well, that's because you should never run an IRC server as root. So I'm going to use sudo. I'm going to run it using an account called IRC that I've created. And now I have it running. So I currently have process ID 7105. And if I do a psaux grep IRC, whoops, I messed that up. There we go. I see that it is running right now. There it is. So it's currently running in the background. Cool. Now what? Well, now I want to open up XChat. Oh, when I go to XChat, it asks me to log in. I'm going to use the name CSUF. Second choice is in case someone already has that, little underscore, username, CSF, my name's Ryan. Now, when you first start it up, you're going to have these networks it's going to try to connect to. I just click on add and then make a local one, edit it, and then change to 127.0.0.1 on port 6667 and hit connect. And I connected to my server that I'm running on my own machine. So do you want to join a channel? Nope, go away. So it says here, hey, cool, man, you're connected to your own server. Fun. So now what I want to do is I want to open up Wireshark. I want to replicate this traffic. I go in here into Wireshark. I go to Capture, Interfaces. You'll notice I can capture on my local interface. Cool. Do that. So I am now capturing on my local interface. Oh, this thing's in the way. Go away. And I want to try something out here. I want to join a chat room. Let's call it Secret Spot. There we go. I just joined Secret Spot. Now I want to type something. Hello world. This is the Secret Spot. Let's tell. Oops. Secrets. All right. Another thing I want to do is I want to send a private message to myself. My name is CSUF, so I just do a /message CSUF, and I say this is a secret. You'll notice a new window popped up down here, or over here. I click on it, and I have a message from myself. It says this is a secret. And I say, oh yeah? Now, IRC gets a bit confused. I'm sending a message to myself, so I'm going to see it mirrored. It's just the way it works when you talk to yourself. You talk to yourself a lot? Yeah, that's how I knew this is what happened. Alright, so I'm talking to myself in IRC. Now I go over here and I stop my capture in Wireshark. Right click, follow stream. And we see here that I joined Secret Spot. This is an example of why Wireshark is a powerful tool. And everything's in clear text, right? So hey, I say, hello world, this is a secret spot. Let's tell secrets. And then I did a private message, right? So here we see private message to the chat room. Here we see a private message to myself. It says, oh yeah? You talk to yourself a lot? And then it's mirrored because it's confused. I'm talking to myself. So there's all my traffic. Now that traffic we had looks nothing like that, right? The traffic we had that encoded silliness going on. This stuff. So how do you decode this? Well, we've covered in session 1 some ways to decode things, but what I'll say is that this is just hexadecimal, and it starts with the &, pound, X, and it ends, well, actually, technically, I guess it, well, yeah, it ends with a semicolon. So I want to get rid of all that. I need to get rid of this because remember, we've already covered how to convert hex to ASCII in Python, but this will break. So what are some ways to do that? There are many, 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 many ways to do that. One way is to take all this, do a replace. What do I want to find? I want to find &, pound, X. Replace with what? Nothing. Boom. Well, look, now I still have that at the end of that. So what do I do there? Well, that's easy. I go to replace, semicolon. Replace it all. Boom. All hex. This is all hex now. This is what I want. I can decode this now. Remember, we talked about this. Python. Import. Bin ASCII. Print. Bin ASCII dot unhexlify And that guy. Boom! How does Wednesday sound? Oh, I just happened to pick the line with the answer. Okay. It's a first one, I guess? Oh, that's weird. All right, so not only can you do it this way, but you can do more fun stuff. I actually created a quick Python script, and close, go away. And it's called Decode IRC. And for those of you programmers out there, here you go. So pulls in a file. That's the first argument provided to the system. Opens it as read-only. What file does it open? It's the first argument. And it prints, hey, I'm going to decode that. And then for every line in the file, it does a regular expressions replacement. And it will replace this. No, I'm not going to go into regular expressions in this course, but if you're familiar with them, this means any of those characters. This is OR. This guy right here, when it's put in the brackets like that, it means OR. I'm going to take any of these characters and I'm going to replace them with what? Nothing. In what? In my line. Remember? For every line in the file. And then I'm going to strip any new line characters, and then I'm going to decode it as hex. And by the way, look, I'm doing decode hex, so this would only work in Python 2.7. If I wanted it to work in Python 3, I would just replace this last portion here with dehexlify. But let's take a look at how this works. All right, and I have this called, oh, first off, cat save decode me. So there's our text. I have it as I already saved it previously. Okay, and I want to put that through my script. So I run Python and decode IRC, and then my saved underscore decode me. Bam. Decoding saved me. And how does Wednesday sound? Great. What time? 2 p.m. Okay, I can't wait. So there's a crude way of using Python to do this decoding. Or heck, you could have just manually gone to an online hex decoder and typed it in. But either way, we just found the answer. So the answer is Wednesday. Okay. So now what I want to do is go over level 2. I was going to still keep level 2 as homework, but I have to be honest with you here. Level 2 was very challenging for my team. So I have a team of industry professionals, especially those with 10 plus, 15 plus years in forensics, and we were stuck on level 2 of this particular challenge. 3 and 4 are ridiculously easy compared to level 2. So because of that, I'm just going to go ahead and go through level 2 in the next 10 minutes and then assign pretty much level 3 and 4 as homework. And by the way, for level 3 and 4, if you were stuck on 1 or 2, 3 or 4 are a lot easier. In fact, use the tips you're going to learn right now when going through level 2 to find out how to do 3 and 4. Okay, level 2. Did anyone try level 2? Those of you in the chat, did you try level 2? Ask the question in the chat there. Let's go. First off, you have to go away. This has to move to the trash. Okay, okay. I couldn't take it. All right, level 2 PCAP. I'm going to open it up. Oh, by the way, I'm sorry. When you send me, or if you would have sent me, oh, I just realized you guys don't have level 2 PCAP. Oh, that was an oversight. Ooh. Hold on. I'm going to put the level 2 PCAP on drive. Yeah, I had the TrueCrypt file on there. I just realized that. Okay, okay. Yeah, so there was one student who sent me the info. So Ryan, not me, the other Ryan, got the answer to it. We also had another student last night who sent me the info. Who is it? Wasn't it you? Patrick, right? Yeah, it was Patrick. Okay, cool. Yeah, Ryan and Patrick got round 1. I gave them the password for level 2. So no one has yet solved level 2, and pretty much what I'm doing at this point is I'm just skipping level 2 by showing you guys additional methodology, and I'm going to do it within 10 minutes because it is really, really difficult, and I'd rather have you focus on 3 and 4. Pretty much what happened with level 2. So, okay, in that case, let's do the following. All right, go away, go away. All of you guys go away. All these screens go away. Okay, cool. Workshop. Session 2. Level 2. Oh, I didn't copy the HTML file. That's easy. Boom. There it is. What? Cool. The level 2 file says, Betty attempts to keep her tracks covered as she establishes a meeting location with Gregory. Answer the following question. What city is the destination for the meeting? So some of the things that you should be doing, you should build keyword lists. So what do we really have? We have these lines right here. So I'm going to copy this. And I'm going to go into keep note. I have Betty attempts to, okay, so this is what I have here, right? And I'm going to make a new page and call this keywords. What are some keywords here? All right, Betty tracks meeting location Gregory city destination, and then we already had meeting. So I would consider that decent. I don't know about tracks. I don't really like that, but it doesn't hurt to have stuff more, so whatever. So keywords that I have, those are my keywords, right? So what's one thing you can do in Wireshark? Well, you can search. You can search for keywords. It's pretty easy to do that. So when we search for keywords, we're going to find some fairly good stuff. Level 2 PCAP. Search, you just go to Edit, Find Packet, or just do Control F. And then, if you remember from last time, you change it to string, and then change it to packet bytes, meaning the value in the actual packet. And I'm going to search for Betty. First thing that pops up is frame 2644. Let's take a look at it. Follow TCP stream, and I get this silly stuff. What's this? What am I looking at? What's this right here? I don't know. What is that? Well, take a look up here. What type of data are we looking at? Well, it tells you. The content type. x-www.form-url encoded. The character set is UTF-8. I want to know what this is. Requests equals. What is that? Well, here's how I can find out. You can use Python for this, but I'm just going to cheat and do it the easy way. Well, you can use anything for this. You can do a lot for this, but I'm just going to cheat here and use this. So I put that in there and I click decode. Hey, look at that. It decoded it. URL encoding, by the way, is what's used in URLs, hence the term URL encoding. You probably have seen stuff like this. In URLs, you can't have spaces, but %20, %20 is a space. So, for example, I'm sure there's a 20 in here somewhere. There's probably, yeah, there you go. So space. Space, 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 space. But anyways, decode. And then I have this. Well, this is also kind of difficult to read for me. It's just so much to read. Oh, goodness. So you can read through it, or you can also text filter this stuff out. So let's do that. Oh, I don't like this text filter program. DFAT doesn't do a very good job of that. So let's, I'm going to just go into Text Wrangler. On my other operating system, and I'm going to cheat. Let's see, what is that, new line? Yeah, such a that. All right, I just replaced the new line characters, and so I got this. So it starts up. Hi, Greg. I'm so sorry I no-showed. I wanted to make sure you didn't bring any friends. We can try to meet up again, though. Here's the password for where we should meet. And there's a password. Now, how did I find that again? How did I find the password of secret weapon? I just did a search for the word Betty. That's her name. That was in my keyword list. That's all I did. So the subject is sorry. It was sent to Death Merchant, who's using AOL, from Betty. Betty Swindle. Swindle. I get it. I get it. I see what they did there. All right, so, okay. And then here's a non-HTML version of it here, it looks like. Yeah, plain text body. I should have read this one, sorry. So, secret weapon. All right, so now we have a password, secret weapon. Cool. What do I do with that? I go to keep note. Secret weapon. Save it. All right, so what else do we want to do here? Well, essentially what we're going to do is we're going to need to find what that password goes to. The reason I'm going over level 2 right now is because finding that and understanding what it is can be a massive pain in the booty. So I'm just going to do it and task you guys with a much funner and much cooler level 3 and level 4. So level 1 is good. If you haven't done it yet, go through it just like I showed you, but focus on 3 and 4. I'm going to show you how level 2 technically is done, though. I'm not a big fan of it. So in level 2, we clear this out. We go over here to statistics, and we look at conversations. And we sort by bytes. See how I sort by bytes here? And I have these guys. I have the Hewlett-Packard going to the Cisco. I have the Dell going to the Cisco, and then right here I have the Dell going directly to the Hewlett-Packard with a byte count of 865938. If I right-click and select this filter, when I scroll up and down, I have this continual TCP traffic. What is this? What's going on here? Right? What's happening? I can find out. I right-click and go to Follow TCP Stream. All this nothingness, and then at the very end I have the response, which probably just says, yeah, I got it. So if you look at the entire conversation, we have that little bit, and then we have this very even number here, 819200. If you're familiar with multiples of 2 or memory sizes and disk space sizes and all that other fun stuff, you'll probably recognize that number right there. So, what is that? Well, this is actually a file. Now, the reason I'm doing this is because this file doesn't make any freaking sense. You can filter this like this and then click Save As, Desktop. File. By the way, Bless is the name of probably one of the better hex editors for Linux. And in Bless, I'm going to open File. Here's the problem. See that right there? If I go search the internet for that to be a file header, I'm going to fail miserably. And the reason I'm going to fail miserably is this file does not have a file header. So what type of file is it? Well, yeah, about that. My team took forever to find it. We eventually just came up with a cockamamie idea that ended up working, and we were fairly confused as to who would have normally thought it through. So I'm going to fast track you on this. When you have a file and you have no idea what type of file is, you can evaluate it in certain ways. Okay? There's something called entropy in a file. And a file's entropy refers to the randomness or the occurrence of the possible occurrences of particular characters. And I give in your Word document, I give a thing here, file entropy, and I say the amount of entropy in a file can tell you if the file is encrypted in some way, shape, or form. And then I give you a link to Entropy Explained, and then a quote. The closer you get towards truly random data, the closer the entropy value will be to the maximum value of 8, meaning there's no pattern or probability to guess what the next value might be. What? Okay, whatever, man. So I'm going to open up a different operating system to show you a tool. There's a tool that I gave you guys a link to, and it's called histogram. No, it's not. Sorry, it's called ByteHist. What ByteHist does, let me change my screen here. There you go. All right, this is just Windows Windows 8. Just ignore, this is one of my malware VMs. Just ignore most of the stuff here except for this guy right here. A program called ByteHist. When you open up ByteHist, you can evaluate a file to look at a histogram of the file's content. So I made a text file here called testing. And you know what, let's delete the contents and say, hello there, this is written in English. Save it, run ByteHist on it. Oops. Take a look at that. You see that? It's not the biggest on your screen, but let me center it there. You're looking at a histogram, the frequency of occurrence of various characters in that text file. We use the English language, and therefore these guys right here are the letters that you're looking at. If you look at a histogram, oh, and on the bottom, by the way, it shows the frequency of occurrence type of thing, how many different letters or characters are encoded in there. So when you look at something like this, you can throw off the scale by doing something as follows. I'm going to put a bunch of Y's in here. Y. And we're just going to go ape with it, save it, close it, and run histogram again. Or, sorry, ByteHist, to generate a histogram. Look at that. All of a sudden, my ByteHist now shows one massive line going straight up. What about the other characters? Well, on the histogram level, they don't matter anymore because there's so many freaking Y's in this document. Histograms like this give you a good heads up on when something is encrypted. So let's take a look. I have a TrueCrypt volume on my desktop here, which, by the way, is the answer to level 2. It's a TrueCrypt volume. How would you have known that? I would have probably never known that unless I entered into a competition and a buddy on my team said, maybe it's a TrueCrypt volume, after like half an hour of all of us wondering what we were staring at. And we said, why would you think that? And he said, well, because they don't have file headers. And then he said, what other files don't have file headers but are encrypted? And we were like, oh, that's a good point. How do you know it's encrypted? Well, if I open up ByteHist and I take a look at the, what did I call it, level 2 TC, right? There you go. Check that out. What? Everything is uniform. Encrypted data spreads everything out across all the possible character encodings. It's actually how you compress / encrypt the document. It's part of how that technology works. Go look it up. So if we look at this right here, that is completely different. That is so uniform. That tells us right away it's encrypted. So when you run this file, it's Linux compatible also, by the way. I just happen to use this VM right now. When you look at that file, what you would notice is that it's encrypted. You would then notice, okay, bear with me, it's encrypted because that histogram, all right, and it does not have a file signature. If you go Google files without file signature, you'll get a heads up that basically you're going to run into something like that. So what is it? It's a TrueCrypt container. Okay, I don't expect you guys to guess about what the files are. The purpose of this is when you're carving out files, you look at the header and use that document from Gary Kessler that I showed you, and you say, oh, look, it's this file. Let me carve it out. And you carve it out, and there you go. I don't want you to just have to deal with these weird... This is the weird level of the challenge, more difficult one. So what do we do with the file? Well, it's TrueCrypt container. All right, so let's share my screen out again, and let's wrap this level 2 up. Okay, on the desktop, we have this thing called file that doesn't make any sense. Well, we think it's a TrueCrypt container. It does not need a file extension, by the way. I just put one on there right now. So I'm going to run TrueCrypt. I'm running it in Linux right now. You can run it in Windows, Mac OS. The Mac one works just fine. And I click over here at the bottom right, select File, Desktop, File.TrueCrypt. and then I hit mount. I still have no idea if this is actually a TrueCrypt file. Display password. Uh-oh, I need a password. Well, we have a password. This was the password that was provided. So I put in the password, and this is how you know it's a TrueCrypt volume. If it mounts, it is. If it doesn't mount, you have no idea. So I hit OK. Hey, look at that. It's a TrueCrypt volume. And in here, I have a picture of Las Vegas. So that was oh, and there's also a note. What's this say? Oh, see you soon, Betty. She says, see you soon, and there's a picture of Vegas. That's the answer. The answer to level 2. Where are they going to meet? Vegas. So level 2 was, again, much harder than I would want you guys to necessarily go through. I did pose it for those who were able to complete level 1. But if you're able to complete level 1, or you're able to follow my instructions for level 1 that I provided today, level 3 and level 4 be a lot easier, like way easier. So don't get thrown off when you just looked at that level 2 and you're like, what? Don't worry about that. Level 3 and 4 are a lot easier. Remember, Control F, search. Very important. Okay, covered histograms, byte hist, and look at that, just near the 2-hour mark. Awesome. So, let's see, chat room still quiet in there. Yep. Okay, cool. I don't have anything else to say today. Done with session 2. So the assignment, if you will, is to take a look at level 3 and level 4. Now, what I've done is level 3 and level 4 are currently sitting on the Google Drive. They're listed as level 3 TrueCrypt and level 4 TrueCrypt volumes. I would like you all to use TrueCrypt to extract those files. And part of why I'm doing that is because in forensics, you're often going to want to encrypt your data, and TrueCrypt volumes used to be the de facto standard that everyone used, unless you know now that the website was completely shut down, the project was canceled, and no one knows why, to be honest. No one still knows why. But for our purposes, whatever, it works just fine. There is a level 3 password for the chat. There, and I will upload the file of it to Google Drive. In fact, you know what else I'll do is I will just give you guys a level 3 HTML file too. How about that? Here's level 3 HTML and PCAP, because you're not competing to get that necessarily. If you solve level 3, if you think you solved it, if you just want tips or hints or anything, just send me an email. I have no problem with receiving emails and responding. Just send me an email. Hey, send me an email. So when you send an email and you're like, hey, what's this? I'll give you some hints and tips, you know. But if you solve level 3, I'll give you the password to level 4.tc, which is the TrueCrypt container, and then you can just open that bad boy up, and then you have level 4. So remember, make a keyword list, keep notes as you go, and good luck. And that pretty much wraps up session 2. Cool. All right, I'm going to stay in the chat room for a little bit over on that monitor and see if there's any questions, but otherwise I'm going to go ahead and wrap up. So, see you guys.